So I think I'm going to upload them to YouTube. I'm not sure if I can do that on Blackboard. I'll double check. That would be simpler, I guess. And yeah, so can everyone hear me?
Yeah.
Yes?
Yeah.
Okay,
Yes.
okay. All right, perfect. Okay, yeah, that's cool. That's the important part. And then the second part's the evaluations. So on Blackboard, I'll be using the assignment tab to give you guys your weekly homework assignments. And the questions will correspond to exercises in the textbook that you'll finish. I believe this week it's like 5 or 6 exercises. So you do the underlined ones, take a picture of them or scan it, and then upload it in the assignment tab. Have you guys done that for other classes before? Yeah?
No.
Okay. No? So if you have any trouble with that, just email me. And I'm going to make it so you could make multiple submissions. So don't worry if this first go around, don't worry if things mess up or whatever. The non-underlined questions are meant for guiding you to completing the underlined ones. So I assigned the questions so they lead up to doing the homework questions, which are generally the most difficult ones in each set. So yeah, there should be like some progression. So doing the homework is definitely going to still help you guys, or doing the non-graded homework is going to definitely help you guys do the graded stuff. And then for final exams, since we're for sure not meeting again this semester, the exam is going to be a take-home exam. So I'll just give it to you guys. I'll give you guys like the same sort of thing you got for your midterm, just maybe a little bit longer, and you'll have like a week to do it.
Will that be online, or will we have to take like a picture or like an email format?
I think I'll try and make it online. Yeah, but yes.
Will we be having like SI appointments online or?
Yeah. So Thomas is gonna organize them through Blackboard.
Yeah, through the Collaborate Ultra, we'll have sessions. I'm still trying to figure out how that'll work.
Yeah, I have to add Thomas as a course creator, so that's what our first step, and then the rest can happen after that. Yeah, so there'll be SI sessions, but they'll be online.
All right.
Yeah, and just generally, also about office hours. So that's something I didn't really mention yet, but I'm not. If you guys want to meet with me one-on-one, just send me a message and we can meet over Zoom. Since there's not really much in the way of schedule constraints for me. So anytime you guys want to meet up, just tell me and we'll meet up and go over derivations. Yeah. All right, I think that's it for the general stuff and how this course has changed. So make sure to check out the assignments tabs. I also have to update the syllabus as for what we're doing for our schedule. We're gonna do like 1 week less of content, and I have to still decide what we're gonna remove. It'll probably not be derivations because that's the fun part of the course. Okay. So today, my plan is to do a quick review of the stuff we were doing before we left for March break or the spring break, because I figure a lot of you guys probably are rusty on derivations. I know a lot of you said you would go home and show off to your family how good you're at doing derivations and stuff, but I didn't believe that. So yeah, we'll practice them. So one of the things we covered before we left for the break was strategizing derivations. So we were looking at derivations that were taking maybe longer than a couple of steps, something around like 8 or 9 steps, and how to think through doing those derivations. So there were 2 main ways to strategize. The first is to work backwards. So that was one of the first things we covered. And I'm just going to put up a simple derivation here that we can work backwards through. So let's say we've got something that looks like this. I have to get used to writing on my screen. Okay, and then we have a conclusion that looks something like this. HC.
Number 2, is that FD or FA?
It's FA. Oh, this one is FB. Okay, yeah. CD. Okay, yeah, this is still a work in progress, so I have to get used to writing on the my screen. Okay, but this will get better, I swear. All right. So
Is that just a P after FA and GB?
yeah, that's a P. Yeah, premise. Okay. So let's say we've got this argument, and we want to do a derivation. So one of the tips so in order to complete the derivation, we have to figure out what rules of inference are going to lead us line by line to the conclusion. So it's sort of the thing we're thinking about is trying to choose a rule of inference that's going to help us get there. So how do we decide which rules of inference to use? That's the question. And the way this working backwards strategy helps you is it narrows down which rules you're looking for. So it helps you come up with goals and rules that will get you those goals. So for this derivation, what would be the last rule you would use? So if we're working backwards and we're trying to get this this bottom thing here, what rules?
Introduction.
Stebby, what'd you say?
Conjunction, introduction.
Yes. So we can, the way Sebi got to this answer is he looked at I assume he looked at the premises and saw that there were this well-formed formula did not exist in the premises at all. So we have to construct it. We have to build it up from smaller parts, these smaller parts. So the way that we do that is, the only way we can do that is by using introduction rules. So that narrows down and helps us think through what rules we're going to use. Okay, so we can write conjunction introduction on that last line. How does that help us? Well, it helps us because knowing the way conjunction introduction works, I'm just going to see if I can. So conjunction introduction looks like this. Once we have P and Q, we can get P conjunction Q. All right. So we know that conjunction introduction looks like this. Conjunction introduction. What that lets us do is write down the components for conjunction on the lines coming before it, working backwards towards the premises. So the key part of this would be GD disjunct FB. And then the P part would be HC. Does that help you guys understand how this working backwards works? Yeah, so in the red, we've got the schema for that rule of inference, and knowing what the components are for this main connective allows us to break those apart and sort of work backwards towards the premises.
For the final answer, is that a GD or is that a CD?
That's it's a CD.
Okay.
And I've confused myself because that's
Yeah.
over there, yeah. Okay. All right, so once we know that we have to now get to HC and CD disjunct FB, we can work forwards a little bit and try and get those on their own. So one thing we know is that if we're going to break down these premises, the easiest rule to use is conjunction elimination. So conjunction elimination allows us to get FA by itself.
Oh no.
My headset's running out of batteries. All right, if that happens, no big deal, but I'll have to go charge it. Okay. Okay, there we go. No. One. Okay, and once we have those on their own, can anyone see a clear path to getting to the lines that we need now?
So in line 1, is it FD and GB?
It's FA, and this is FA too, so those are both FAs.
Oh, so 4 is FA.
Oh, yeah.
Okay.
Yeah, my writing's so bad it confuses me too, so.
Well, so with GB, we could pull out HC from number 3 using a conditional elimination, right?
Yes. Using conditional elimination, we can pull out HC. So using line 3 and 4.
And then
Wait, no, 3 and 5.
We could pull out 2 because we have FA or FD, whatever that is.
Yeah, we do. Yeah, it's FA. And we can get this line now. Okay, and then we finish off this derivation with okay. So does that make sense to everybody? Does anybody have any questions about how we use the working backwards strategy to do this? So what working backwards did here is it narrowed down are thinking about what rules of inference we're going to use. So we figured out what the last rule is going to be, and using that, it helped us work backwards a couple of lines that showed us that using conjunction elimination was going to get us towards where we want to go. So an important part of working backwards and just figuring out what rules you want to use is narrowing down whether you want to be using, whether you're going to be constructing or eliminating. So the rules of inference come in two categories. You either have elimination rules or introduction rules. And if you can sort of see whether or not you want to construct a larger well-formed formula or make a larger well-formed formula into a simpler one, that's going to help you think through which rules of inference you're going to use. It eliminates half of the candidate rules that you could possibly use. Okay. All right, let's do another derivation. One thing I'm curious about right now, are you guys able to also draw on this whiteboard if you wanted to?
I don't think so,
No.
because this is screen share from you.
Okay, that makes sense. All right. Okay. So the next thing, or what I'm going to talk about now, is introducing conditional introduction. So this is a really exciting time because the assumption rules are going to make our derivations a lot more interesting. Who here has been thinking that derivations haven't been interesting enough lately? Sebi? Okay. Yeah. So if you've been thinking that, then you're going to really love this. We actually covered it the first class that we did any sort of derivations in. Can anyone tell me like what the schema looks like for conditional introduction?
It's like you have a P and then like a dot and then a line and then P then Q.
Mm-hmm.
Or if P then Q, excuse me.
Yes. Okay. So in red here, we have the schema for conditional introduction. And it's got a part of the schema that's new to you guys. Or there's a couple of parts, right? So I've got a bunch in chat. Oh, okay. That's cool. Thank you, Sophia. All right, I got to keep this chat box open.
Can we not see what they asked you?
I think that, no, because Sophia sent it to me privately, but she was just saying that there's a way to share the whiteboard. Okay. Yeah, I didn't realize there was a chat box. That's cool. Yeah, so anyone who doesn't have a microphone, if you guys just use the chat box, I'll be able to answer your questions, and I'll look at them now. Okay. So conditional introduction introduces two new things to the inference rule schemas. So you see a vertical line there, and that vertical line is something we talked about the very first time we introduced derivations, and it's an assumption line. So it's saying that that everything that falls under that line is a sub-derivation of the original derivation. So the way you want to think of these assumption rules, or rules like conditional introduction, is that they allow you to introduce a new assumption into the derivation. So a well-formed formula that basically comes from nothing. And and then complete a subderivation, which then, once the subderivation is complete, allows you to introduce conditional into your main derivation. So if one of your goals is to build a conditional, like let's say we've got an argument that looks like this. The conclusion is a conditional. The first premise is something like GBHC. Okay. So really simple argument. Before I introduced this rule, we wouldn't be able to do this argument, right? Because we would have no way to go from this conjunction to the conditional. But now that we have conditional introduction, we have a way to do this. So according to this schema, in order to derive the conditional, I need to assume the antecedent. So I'll just label those parts on the main derivation. The antecedent is here. The consequent is here. So what would that mean I'd have to assume?
FA.
Yes. All right, and the way we label that line, so if you guys remember, every line should have a justification next to it. So you just put an A next to your assumptions. All right, and then you start your scope line from your assumption, and it'll go through until you close off that subderivation. All right. So on line 3, this is going to be a really short derivation. We end up getting our Q right away because we can take GB from that conjunction through conjunction elimination on line 1. All right. So
Do you have to add an A to assume GB?
so
Like as a justification?
Oh no. So for the justification, I list just 2 to 3. So,
No, I mean for GB because it's under the assumption rule line.
oh no, you don't. Yeah, because GB actually comes from, I could have got GB outside of the assumption rule line.
Okay. Right.
So GB, I could have gone here and did line 2 just GB by itself, and then if I wanted to introduce GB later.
Okay.
Yeah, but so I've set it up here so that it lines up nicely with
When can you make assumptions? Is there
So-
specific other rules?
you can make assumptions whenever you want. So there's no rules with assumptions. But there is strategy around it. So even though it might not be against the rules to make an assumption, it might be bad strategically to make one. And this is something that's going to be new to derivations now with assumption rules. The fact that you can actually make your derivation impossible to complete by assuming too many things. So it adds an extra neat element of strategy to derivations. So I'll just go over quickly what we did here and the way that you want to think of using this new rule. So you only ever want to use conditional introduction when you actually want a conditional. So one thing that is really tempting with assumption rules, because assumptions allow you to assume anything, is to just assume anything and just hope it works out, right? That's bad. That's a bad way to strategize in all aspects of life, but especially for derivations. With assumption rules, you want to, first of all, think backwards. You want to think, what am I trying to get out of using this assumption rule? Do I need a conditional in my derivation? And if the answer is yes, then go ahead and use it. But if the answer is no, you don't want to start assuming things. Does that make sense to you guys? Yeah. All right, here's another interesting aspect of assumption rules. So in the scope of an assumption, you're going to be deriving things. So GB, for instance, we derived in the scope of this assumption. After the assumption is closed, you can't use any of the things you derived on these lines anymore. So assumption rules introduce what are called subderivations. So they're like secondary, smaller derivations inside of your big derivation. And if you think of conditional introduction semantically, that sort of makes sense. So a conditional, if we're thinking of derivations as every time you write down a line, it's something that's guaranteed to be true if you assume the premises are true. Well, the way that the truth functioning of the conditional operates is that if we can add a well-formed formula to our derivation and then show that we can get to another well-formed formula using the rules of inference, then we've shown that we can put a conditional between those two well-formed formula, because every line of a derivation is sort of a conditional. So FA conditional GB applies. So that doesn't have to make sense, but it's a different way of thinking about it if you guys have been finding the semantic way of thinking of derivations helpful. All right, does anyone have questions so far?
Yeah, I have a question.
Yeah.
So in the conclusion, you got FA, which was derived in the assumption, but the assumption's been closed. And you said you can't use anything derived from the assumption after it's been closed. So how can you use FA in the conclusion?
Yeah, well, yeah, okay. So that's a great point. You can't use anything in the scope of the assumption outside of the line that you use the assumption to derive. So the line 4 is using conditional introduction. So it's the rule that we have the assumption in place to derive. So it's citing lines 2 through 3 because anything in the scope is, I mean, the whole scope is justifying the use of that assumption rule. So the reason that there are dots here is that unlike other rules, assumption rules can refer to an infinite string of lines for their justification. So conjunction introduction just needed two lines to be cited, but yeah, but
I'm gonna be honest, I still don't understand it. Like, I still don't understand what you're trying to say.
Okay, that's cool. I mean, that makes sense. So these are confusing.
So say you wanted to, say this was a longer conclusion. It was like parentheses around that, and then you also wanted GB disjunction like FC, something that doesn't exist. Would you
Yeah.
have to therefore pull out GB again in a separate line because you can't use the GB you pulled out there? Are you able to pull it out?
Yes. Yeah, you're right about that. So I think this will become clear the more we do these things. So let me set up another one for us to do together.
All right.
Okay.
HK and AD.
Yes. Hold on one second.
It's HK and AA. Hmm. Okay. So I am now questioning whether this is going to be able to fit. So let's see. The beauty of not using real Blackboard is I can just drag things. Oh my God. Okay, and now I'm going to draw our schema again. So arrow introduction. P is an assumption. Assumption line, dot, 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 infinite lines, Q, P, arrow, Q. Okay, cool. So let's talk a little bit about strategizing first. What's the last rule we're going to use for doing this derivation?
Conjunction introduction.
Yes. All right. That lets us know that we'll have two goals here. The first is to get FA conditional CD, and the second is to get FA conditional AA. So we can write those.
AA prime, or is that just like AA weird?
It's just AA weird. Okay. So I know that I'll have to use a fair bit of not just introduction, but also elimination rules. But you'll notice that in our premises, we've got all conditionals. So that poses a problem for us. None of those conditionals are the ones we need. And conditionals require 2 lines in order to eliminate. And we don't have any of the requirements for normally eliminating conditionals. Luckily for us, we've got a new rule that lets us assume things, introduce things into our derivation that we wouldn't normally have. And since those things are going to be part of what give us our goals, these 2 conditionals in magenta, underlined in magenta, we know that we can sort of aim for that. Okay, so I'm just gonna, so we know that FA conditional CD is one of the ones we need. So to get this using our introduction rule, let's put our schema a little bit closer. So here P would be FA. So our assumption is FA. And in order to close this rule off, we need to get Q. Q in this case is CD. So we have to get CD on its own inside the scope of this rule. So CD is part of our premises. Since we have FA now, we can eliminate FA conditional GB and get GB on its own using conditional elimination on line 4 and 1. And then line 6, we'll be able to get CD on its own using line 2 and 5. So here we have the P and the Q, and that allows us to discharge our assumption and introduce this this conditional. All right, any questions so far about how we got that conditional using our new rule? Okay.
Wait, so do you cite lines 4 through 6 or just 4 and 6?
Yeah, so 4 through 6. All the lines that this assumption line goes through.
Okay, thank you.
Okay. So the next thing we need to get, we've got one side of our requirements. We've got this first side of this, or first component of this conjunction. Now we need to get the second component. So I'm gonna write that in this purple color. FA conditional A. All right, if that's what we need to get, I'm gonna put this here. What is our assumption gonna be?
FA again?
Yes. Does that make sense to you guys? Why would be FA in this scenario?
Yeah.
Yeah.
Okay. No, oh my God.
So we have to assume it again. We can't use like line 4.
That's right, yeah.
Okay.
So we can't, so on line 6, that assumption was discharged because we used the assumption rule. So that means anything in this area here is no longer in the scope of our assumption. I mean, no longer usable.
Okay, so is that what you mean when you say once the assumption's been closed, you can't use it again? So like we
Yeah.
have to create the new assumption. Okay.
Yes, yeah. So I figured it would help you guys to see a derivation with more than one assumption. All right, so here we assume FA. And we know that in order to discharge this assumption, we'll have to get to AA. Okay, so how do we get there? Well, we're gonna have to go through some steps again. So we have to get GB on its own because the other GB that we have in our derivation here, that one is not in the scope of this assumption. So we'll have to derive it again. Once we have GB, we can get this conjunction. Ooh. Yeah, so Natalie, I'm going to be posting these. I'm recording the whole thing, so it will be posted on Blackboard or YouTube. Is that what you were asking for? Or just to screenshot? Yeah. Okay, yeah. Okay, and once we have this, get AA on its own. Introduction. And then the very last line. So this is our longest derivation yet. 13 lines. Wow. Okay. 13, 7, and 12. Okay. So this shows you how much fun you can have with assumption rules. Does anyone have any questions about how we did this derivation? This is like a medium difficulty one using assumption rules.
Can I ask about, excuse me, about the citation, where was it? For line 9. So we have lines 2 and 8. Would it be 2 and 8 or would it be 1 and 8?
Oh yeah, you're right. It'd be 1 and 8.
Okay.
Yeah. Okay. Yeah, so one thing you guys will notice with the homeworks is that they're isn't any answers. There's no answer key for the textbook. So you'll have to do them and come to class with questions about them, and we can take them up together. That's what I figure I'll be using a lot of this time for, teaching you guys how to go through the homework questions and how to strategize through them. A big part of getting the feel for what patterns to look for when using especially assumption rules is practice. So knowing, for instance, in this derivation that you're going to have to make 2 arrow assumptions, it's something you can strategize, but at the same time, it becomes really obvious how to it becomes easier to think through it the more you are exposed to it, basically. Okay. So any other questions about this derivation? So one thing I wanted to do this particular one, just to point out the fact that here in line 9 and line 10, we needed well-formed formulas that already existed in our derivation on line 4 and 6, right? So for line 9, we were eliminating GB from line 1. But if you notice, we already did that on line 5. So why couldn't we just use that again on line 9, or even use that GB? So the thing that's keeping us from doing that is this new rule we've added to derivations. Or it's not a new rule, it's just one we haven't encountered yet because we don't have these scope lines. The scope lines are separate subderivations where anything that's derived in them isn't usable outside of the scope line. You'll notice there's a break here because we discharged this assumption and we've made this FA conditional CD out of the assumption. We can't use anything we've derived in this area again. That's why we have to do it all over again on this, this part. All right, so it is now close to the end of class. And I guess we'll wrap things up. Just to go over what we've learned so far, I've taught you guys this new inference rule that changes the game a little bit. It allows us to do something we've never been able to do before, which is make assumptions, and then use those assumptions as part of a rule of inference. So there's another assumption rule, negation introduction, that we're going to cover on Wednesday. With these two combined, we're going to have some really fun and complex derivations going forward. So the strategizing is going to, working backwards is something you guys will have to really be accustomed to in order to use these derivations, because going forwards, it's not clear that, you know, FA's, for instance, the assumption you want to make on line 4. It's only once you realize the thing you're looking for is FA conditional CD that you know that you should be making that assumption. Does that part of the strategizing make sense to you guys? So working backwards is really the only thing that sort of rationally tells you, oh, here's the decision I should be making. I should be assuming FA here. Okay, so going forward, Thomas, are you gonna keep the same SI schedule?
Yeah, so I think they start today, so I was gonna try to hold one tonight if I can figure it out at 8 p.m. Yeah, but I'm gonna send out an email to everybody through Blackboard that'll go over the schedule and just some of the other details.
Yeah, cool. And going forward, I'm gonna try and figure out how to get it so you guys can also, like, we can write on the same whiteboard, because I think that would be really cool to be able to share, have you guys do answers and me to critique them really harshly. Whoa, someone just did it.
It was me. I figured it out.
Oh, really?
Yeah. So if I'm doing it on my phone though, you
okay.
Screen and then a little pencil shows up and then you can write.
Oh, that's awesome. Okay, that's really, really cool. All right. Well, we'll work on that later. I hope you guys have fun with the rest of your online learning. And yeah, I'll see you guys on Wednesday.
Bye.
Bye.
Bye.